Okay, so we're going to look at questions. Look at questions involving graphs, straight line and quadratic. We're going to start off with a straight line graph, and it's asking us to find out the gradient and then the equation of the line. So the first thing we've got to think about is when we're doing straight line graphs, then we're thinking that they're always of the form y equals mx plus c. So the y values are always something times the x values plus a number or take away a number. And we can think of that as a standard graph, and basically the C number is known as the intercept point, so it's where it crosses the y-axis when x is 0, and the gradient we find by choosing two numbers on the line, creating a right angle triangle between them, and we work out the change in the x values, which quite often we think of as the run along the bottom, and the change in the y values that we think of the rise, in other words how far up or down we've gone to get from one point to the other on the straight line. And therefore the gradient m, so unfortunately we use the letter m for the gradient, but that's the way it is. So the gradient is equal to the rise over the run, and in some books you'll see it's delta y over delta x, because it talks about the change in the y variables divided by the change in the x variables, or the x coordinates, should I say, because we're talking about straight lines. So when it says what is the gradient of the line, then we're looking at calculating the m value, so the rise over the run. So in other words, we want the change in the y values divided by the change in the x values, and we choose 2 points on the line. Well, this question's kind of given them to us to give us a hint, and we kind of imagine then the right angle triangle created. So the change in the y values, well, the top here was 7 for the y and the bottom was 3, and the run, well, we had a top value of 2, take away the lowest value, 0. So in this case then we ended up with 7 take away 3, 2 take away 0, and when we divide those we get an answer of 2. So the gradient of this line is 2, and basically what they're saying is for every one you go across on the x-axis scale, we go 2 up. So for every one we go 2 up, so for 2 we went 4 up. So it's a way of thinking about this gradient and how it works, and it doesn't matter where you chose. So we could have originally chosen our 2 points there, and we'd still have had 1 across, 2 up. So that's around about the gradient. Then it says what is the equation of the line. Well, what we've got to recognise is that we already know the gradient was 2, so we know this line is going to start with y equals 2x, and we look at the intercept point, so where it crosses the y-axis when x is worth 0, and we can see that it's the number 3, so plus 3 because it's positive 3. And we should check that this works, because the whole point of having an equation of a line is it tells us the y coordinates for any x coordinates by doubling and adding 3. So if I take the point here, and that has a coordinate of 1, 5, so that means our x coordinate was 1 and our y coordinate was 5. So if I try that in here to check it, then our y value should be twice the x value plus 3, and twice 1 plus 3 is 5. Was our y coordinate 5? Yep, our y coordinate was 5. So the check kind of confirms that this equation does work for this line. So that's a reminder of calculating the gradient of a straight line and how to put together the equation of a straight line if we know the intercept point and the gradient of the line. Now we're talking about drawing graphs, so we're looking now at drawing, well, this has got power 2, and power 2 graphs are known as quadratic graphs, and we should remember that the quadratic graphs then always have this kind of U shape to them with somewhere a line of symmetry between them. So in other words, the coordinates coming 1 across on the x-axis that way, 1 across on the x-axis this way, there should be some symmetry between them. And that's a way of checking these. When the x values go up in ones, then there should be some symmetry in the y values here. So let's have a quick reminder. So when we want to get this, it's a non-calculated question, then we've got to substitute. So we're trying to find the y values. Well, the function we're being given here is telling us that to get the y values we square the x. So if x is negative 1, so substitute in a bracket and then do the function. So we're squaring, take away 4 lots of the x value plus 2. So we go through doing each part, doing the times in bits and the power bits first, and then do the taking away and adding last. So we've got negative 1 squared, or negative times negative, that's what squaring is telling us to do in this case, so that's going to be positive 1. Negative 4 times negative 1 makes it positive 4, so plus 4, and then we've got plus 2. So that gives us an answer of 7. Now that's already given me some confidence because 7 there and 7 there, so it's kind of looking as if there might be some symmetrical pattern going on. So that would suggest if it goes 7, 2, then it should be going 7, 2 that way, and it gives us some idea then of how to check our answers, but we'll work them out. So for this one here then, the y value is square the x, so we've got to square the x value, take away 4 lots of the x value, plus 2. So 2 squared is 4, 4 2s are 8, so take away, so 4 take away 8 plus 2, and that gives an answer of -2. So -2 that. And then to get this answer here, then we take the x value and square it, so the x value was 4, take away 4 times the x value and then add 2, so 4 squared is 16, 4 4s are 16, and then we're adding 2, so that gives you an answer of 2. Okay, so we do our final check to make sure we've got that symmetry going on, because we know this is a quadratic function because of the power 2, and we should be expecting that u with a line of symmetry telling us there's some symmetrical values. And we can see we go 7 2 -1, 7 2 -1, and then a value in the middle. We won't always have that value in the middle because it depends on what values they've chosen for x and so forth, but it seems to be that the check is working here. So the question then says we've got to plot these values, so we've got a grid given to us. So we look at the table and it told us that we're working with -1 7, so this gives us a coordinate of -1 7. So basically we pair these up to get our coordinates, because our coordinates always have an x number and a y number on these graphs. So we take our table and we plot the values. So the first one was -1 7, the next one was 0 2, the next one was 1 -1, the next one was 2 -2, next one was 3 -1, 4 2, and 5 7. Okay, so we've got our points plotted and we know it's a U shape. It has to be a curve, so we don't join these together with straight lines. We do a freehand curve, and one of the ideas that helps is to kind of ghost it by putting your pen just off the paper and then just basically going through. So we're going to go through the points as best as we can, following the points. Okay, so we end up with our best U shape possible, and that should give us the full marks. It doesn't have to be perfect, it just has to show that you understood it's a U shape and it goes through the points with a curve rather than straight lines. So that's a reminder of graph questions involving linear graphs y equals mx+c and quadratic graphs involving powers. So if we just zoom down a bit, and then we can see the whole question in one go, and then we can see what the question was asking us to do, and then drawing the same function on the grid.